Okay, it's 1 o'clock. We should get going. Welcome everybody to our next HDF clinic. I checked our Google worksheet before the meeting, and there weren't any questions there. But let me just make sure that that's still the case. Let's see. Yeah, there aren't any questions. Okay, but we can jump right in. But I'll pause. Are there any questions from the audience at the moment? No? Okay, then we'll just press on. So, okay, so SWMR Beta 2 is still available for testing. If anybody's interested, please go ahead and try it. And because, yeah, I think the plan is to release it with 1.13.2. If you go to the GitHub page, there is a little bit of a release schedule, and I have not heard of any changes to that release schedule. So 1.13.2 will be out, I believe, in July at some point, and I think VFD SWMR will be part of that. And so if you're interested, check it out. We just released HDFView 3.1.4, and there was a little bit of confusion, as one user pointed out. First of all, and that may or may not be a very fortunate choice of versioning these releases. There are now 3 minor versions of releases, so based on different HDF5 versions. So there is the HDFView 3.1x series, which is based on HDF5 1.10. Then there is the 3.2x series, which is based on 1.12, and then there will be at some point a 3.3 HDFView 3.3x series, which will be based on 1.14. And the user in this thread here correctly pointed out and said, hey, where did 3.2.0 go? And yeah, what about these different releases? Are we going back to 3.1? So the 1 is explained what I just wrote down here, or what Alan also replied in the forum. But then it turns out that there is actually a bug in 3.2.0. It has to do with, I believe in that release, if you look at the release notes, Alan transitioned to the new references. So there was a new style of references, and this combination of variable length sequences of references turns out to be problematic in attributes. So I believe that is used, for example, in dimension scales. Yeah, there is a bug of some sort, and leading actually to a crash. I think that's what Alan commented. So for the time being, stay away from 3.2.0. And I believe also this release has an issue with variable length sequences of a reference type, but then at least it doesn't crash. I believe Alan commented and said that it just doesn't show a value for that type of attributes, and so he is investigating / fixing what's going on there. But yeah, that transition to new references obviously caused a few issues. Any questions so far? No? Okay, then we'll just move on. Lots of things, but again, this is a very subjective selection here. This is a question that comes up periodically related to identifiers. So people would like to determine, given 2 identifiers, if they refer to the same object. And so let's quickly recapitulate how this goes, because the user in a way strayed into the user-defined identifier space, and that's why I'm bringing it up here. But before we go there, let's recap. So all this identifier handling is done in the H5i module, and I linked it here. So if you click on that, it takes you straight to the reference manual. And as probably most of you know, these identifiers are transient, meaning they are specific to an instance of the HDF5 library that's loaded in the context of a process. And when that application shuts down or that process goes away, those identifiers also go away. And also they go away, for example, when you close an object, you free the associated resources and whatnot. But you have to be aware of, and that users sort of maybe mix things up a little bit there. There are two types or classes or flavors of identifiers. There are sort of predefined identifiers that come built into the library, and then you as a user, if you choose to create your own identifiers to refer to things in your application, you can do that as well. For predefined identifiers, oftentimes in documentation, you might read comments like, okay, these identifiers or handles, they refer only to HDF5 objects. Well, that was not entirely true previously either, because, for example, when you open or create an attribute, that creates a handle either, and we usually do not consider attributes as objects. But then if you look at, there in the H5i module, there is a function H5i get type, I believe. Go ahead. Okay, sorry. Then if you call H5i get type, that returns an enumerator in this enumeration here. And if you, again, it's hyperlinked, but if you click on that, if you go there, you will see that, I'm not going to zoom in here, but you see there is a lot more than sort of groups and data types and data spaces and so forth. Nowadays, you might also get as a reference to a wall, or VFL, and so there is a lot more happening in this predefined ID space than there used to be. But then on top of that, so first of all, there are more predefined identifiers today, but then there are these user-defined identifiers if you choose to use them in your application. And yeah, the sort of the programming model is basically you create call it an identifier type that you would register with the library. And then once you have registered that type with the library, you can then create identifiers for objects that you consider to be of that type. And you can go ahead and use these identifiers, and they have the same characteristics that other identifiers have. In particular, you have to close them to free any kind of associated resources. And however, if you go to the reference manual, for the user-defined ID types, there are certain functions. Well, first of all, here in the documentations, there are a few examples of how to create your own identifier type, and then how, in this specific case, for an integer, arbitrarily speaking, you can create an identifier for an integer. I'm not saying that that is particularly useful, but it illustrates the use of the API. There are certain functions available for user-defined identifiers that do not work with sort of the predefined identifiers. And that's what this user ran into. He called this function H5i object verify, and then the maybe a little cryptic error message that he got was object Adam unable to find ID group and cannot call public function on library type. So what that basically says is, yeah, he probably had an identifier of a type that falls under the sort of predefined category. And then, yeah, if you call a function that is really intended to be used with user-defined identifiers, then you would get an error message like that. So this is just sort of to clarify that, but I believe that that was actually the premise of this question is, I have two identifiers and I want to see if they refer to the same object. So then the procedure is assuming that this object, yeah, is a group or a data set or a committed data type or something like that, that you would use, there is a function called oGetInfo, and that's actually a macro. So depending on your library version, that's going to be oGetInfo1, oGetInfo2, I think the count stands at 3, oGetInfo3, you can use that to receive a structure that has fields, and among the fields, there is one, depending on, again, which version, there are also versions of this info structure. There is either an address in there, or in newer versions of the library, there's a token in there. And then you can do a comparison of these addresses or tokens as a sort of as a first order check if these two objects are identical. Now, this is not necessarily 100% because I think you can say if these addresses or tokens are different, then it's very likely there's a good chance that they are also different objects. However, in the case of tokens, it then depends on, so tokens, that would be the situation in 112 and higher, where there might be some kind of vol, some virtual object layer plugin or connector involved. At that point, it's really at the discretion of the vol connector to determine what equality or what when two objects are identical. And so that vol might have its own ideas of what constitutes equality, so to speak. So there is still some room for error here. But other than that, yeah, that's sort of the standard way, or a relatively safe way of establishing object identities, so to speak. Okay. Any questions? No? Okay. Then there was another question here that comes up periodically. A typical use case with originally the core VFD, users have the ability to create HDF5 files that are backed by just buffers in memory. And that's why it's called the core VFD. And yeah, the beauty of it is that as long as you can fit that HDF5 file into memory, let's say you have a machine that has 16 or 64 gigabytes of RAM, then you might be able to fit that entire file into a memory buffer. And what is very common is to, if you have, for example, different applications, and these applications, for example, use shared memory to communicate, or you have two applications that are communicating over sockets or something like that, or over 0MQ, or then you can use a memory-backed file either directly in the shared memory situation, or in the case where there is a network involved, you can then take that buffer, which backs that HDF5 file, transmit it over the network to another node or to another computer, so to speak. And then on the other end, use that buffer, open it with the core VFD, and just work of that image. And the user, I think, he actually sent an example. I think in his case, the problem is that I think he closes the memory-backed file before he actually wants to use the associated buffer in another process. And so in that case, yeah, the default, and I think in his case, he did not implement, you can define so-called H5 image callbacks, so you can implement, you can overwrite what happens when an image gets freed, or when an image gets allocated and so forth. But the default implementation for free would just call the free function. And so I think in his case, that free function gets called when he calls close. And at that point, that memory buffer is gone. And then I can see, I think, in his application that he then tries to use that pointer. That's what it is, essentially. And that, yeah, I think is not going to work. But the logic is really, yeah, so you can create a memory-backed file with the core VFD, and then you can make changes to that in the sense that, yeah, you can create objects in there, put data in there, modify the data and whatnot. And then you can create a file image from that. Yeah, I think as Elena pointed out, you want to call flush, and just to make sure that everything is in a consistent state. Go ahead. Sorry. And then when you have that pointer, that's what it essentially is, of that space, typically in a shared memory segment, or you may have to transfer it over a network to another machine, then yeah, you can create, again, using core VFD with the right access property list, another memory-backed file in this other process, and basically the functions that make that happen, in addition to the set fapl core function, is there are these H5P get or set file image functions that basically either retrieve pointers or use a pointer that you provide to that buffer that contains the file. So this is that's what this was created for and is used for. These file images, and yeah, so the user is definitely doing trying to do the right thing. It's just there is a little bit of a mechanical glitch, maybe, how he is trying to do that. And his example is maybe also a little overcomplicated, because he should maybe really strip out all the extra code and just provide the code that deals with the buffer management and the file handling, and not do anything. I mean, he has H5L iterate calls, I think so. So he opens a file from disk and then iterates and does copying. So that clutters the example a little bit and makes it maybe a little longer than necessary. But he's definitely on the right track, and it's just a minor kink. Okay. Any other?
Question. Since Quincy is here, actually, I have two questions. The first question is that a programming model kind of suggests that you get the size of the file in memory and allocate the buffer of this size. Does it mean that file in memory doesn't fit into contiguous space, or there can be gaps? Why we need to copy? Quincy, do you remember?
Well, the VFD interface is designed to, you could do different things, but at the time we made the choice that the core file driver, which is what's underneath the file image code, is going to use a single contiguous buffer. and it doesn't try to like page in different sections of the file, although it could. And then it would be more like a split, or sorry, a family driver with pieces of the family in memory at a time. But right now it requires a single contiguous buffer to work with.
Right, and that's what I recalled. And then why we cannot just give pointer to this buffer and we ask user application to allocate the buffer?
If you use the callbacks that are in the file image property list that you alluded to, those are available.
Okay, so it can be avoided duplication of the buffer memory space, right?
Yeah, the app could do what they'd like on how to allocate it. It still would want to have a single contiguous address space in memory somewhere. But...
Okay, but then it will be less memory used by application, right? But by default, a user application has to, if it doesn't use callbacks, it has to allocate, find the size of the image, allocate the buffer, and then load the image, set file image.
Well, it's all negotiable there. You can provide an image, or you can provide an allocator, or you can do neither or both. It's really all available.
Okay, so the functionality is available. That's what I wanted to check. And the second thing I wanted to check, if I open the file with code driver from the image, right, it doesn't have a name, and I can provide something like, if I specify for core driver that it's true, so I want to persist in the file, will it work? Because our test uses only false, meaning that it's not backed on the file system.
Well, it should work, but
okay, it should work.
Assuming that the tests are there at some point, somewhere.
Right, it should work. Nothing prevents it to be backed to the file system after it's done.
Yeah, sure.
Okay. Thank you.
Okay, thanks.
Sure.
Okay, then the next one is short. That's just a discussion. We talked about that last time, where initially it appeared that, well, not just it appeared, the user is using one of these high-level APIs, and we discussed they are not thread safe, but then the user said, hey, I'm using a critical section, and does his protection, and he uses a thread safe build of the library, and all cool. But it's sort of a little bit of a dance around. Several people, including Elena, we asked him, show us an example, and he's just unwilling, unable, I don't know, to provide an example. So at this point, he's not, maybe he doesn't understand that he's not really helping himself by constantly evading questions, helpful question. I mean, everybody tries to help, but some people just don't pick up on that, and so I don't really have anything to say on this one. Okay, I'm going to pause here. I have a little bit of an old and new issue prepared that we can talk about, but if there are other questions, let's talk about something else. Are there any other questions? No?
No questions.
Okay. Okay, thanks. Welcome. Let's then talk about, so this is an issue that also, it's one of these issues that comes up once in a while, and it came up recently, but the forum is a great place because, yeah, a lot of these things have come up in the past. So one thing that people have noticed when using SWMR, and I earlier talked about VFD SWMR, but this is the original SWMR implementation, people were reporting issues when they used SWMR and compression. And so I just copied two links here, for example, to threads where that came up in the past. And actually, Elena answered in both cases, and there were just slight variations on each other. And it turns out it's not a bug, it is really a feature. Now, what do I mean? What is really happening here? Well, what people find is typically when they use SWMR, they are writing to a data set. They are that data set is, and they use compression, so it's a chunk data set. And what people find is that at a given point in time, when they sort of write in time steps, so they write chunk after chunk and so forth, or they modify an existing chunk, you have sort of an idea of, okay, let's assume compression is effective. You have sort of in your mind an upper bound where you say, okay, that data size, and for argument's sake, let's assume we have only one data set in that file. You have sort of an expectation of how big that file should be. So if there's just one data set and we assume compression is effective, which means that an individual chunk will typically be smaller than the nominal size of that chunk without compression. So that gives you sort of an idea, and you say, yeah, this is how big that file should be. Now, it turns out in some of these cases, people describe my file is much, much bigger than that. And why is that? Well, it has to do with sort of two things. Number one, some of you may know, and we talked about this in the past, in one of the 110 versions, we introduced file space management. So in the pre-110 versions, file space management was such that free space got reused only in a given open-close epoch, let's call it that. So you open a file, and then you do things. You may create objects and may delete objects, depending on the VFD. But typically, yeah, when you deleted an object and then created a new object, that free space got reused if it was of a suitable size and so forth. But then once you close that file, any free space that existed at this point in the file, that information that free space was available was not persisted in the file. But that changed in 110. So in 110, you could choose to use this new free space management, and you could actually specify the granularity where you say track free space information for everything greater than, let's say, 64 kilobytes or something like that. And that would be persisted, and it would survive this open-close epoch and would be available next time around. However, this feature is disabled in swimmer mode because it would be, I think, definitely for performance reasons, but there might be also reasons related to the implementation complexity and so forth. But so what happened in both of these cases, when you typically in swimmer mode, you are acquiring data, let's say in some kind of streaming fashion or something like that. And then people would be inclined, of course, they are using swimmer, so they are probably using swimmer for good reason, in the sense that there will be one or more readers, the R's in swimmer, where you sort of try to understand, either you do online analysis where you try to also start processing the data as it comes in, or you just peek at the data to understand whether that experiment or your simulation is sort of going in the right direction, or something fishy is going on. Now, what in those cases people tended to do was they either, inside of that loop where they would sort of append data, they would either just write one element on that chunk and then in the same loop call flush, because that way they thought they would help themselves, that the data would sort of appear faster on the reader side, and that is in a way true. However, what that meant was that the library took that chunk and basically put it right into the file, and in swimmer mode, actually every time that chunk gets flushed, new space is actually allocated in the file. And so if you think about that, even though you may have changed just one element on that chunk, you do element by element by element, but flush in the same loop, then you just that there will be space allocated in the file every time that chunk occurs. And okay, it may compress very well, but then again, if your chunk is sufficiently large, you will have practically X, not exactly copies is the wrong word, because it will be sort of incremental versions of that chunk. They will end up in the file occupying space, and then only the final version is really the one, the gold copy, so to speak, that has all the data. So this is what happened here, and leads to this effect of where yeah, you sort of think, I use compression, I use SWMR, everything should be great. But yeah, in your code, you are constantly calling flush, and that's understandable in a way that you say, I want my reader to see updates pretty quickly, but you are really achieving in a way the opposite effect. And now the question is, well, how can you get around this? Well, fundamentally, you cannot get around this, but you can sort of maybe alleviate that a little bit. That if you are updating a chunk, well, as you are updating that chunk, don't constantly call flush in that same loop. So just make sure that your chunk cache is big enough so that that chunk can sit in there, and as you update it, you write to it, and then once it's sort of filled, then you can call flush, and then it gets written, and your readers will see it. But of course, yeah, if you say, well, the chunk is so large that I need to keep flushing because the chunk is so large, otherwise my readers would never see anything, that's tough. And then, of course, there is this other thing. There's this thing called an edge chunk. So if your data space does not quite cover the full chunk, we call this an edge chunk. There's an optimization in the library that you can tell the library not to compress these edge chunks. So that will also alleviate this issue for edge chunks, albeit only. And yeah, so this is just something that keeps coming up. The bigger picture here is really, unfortunately, a lot of this information exists in a forum. It's hidden in documentation here and there. And I think what we should do is we should create what I would call an HDF5 feature, in parentheses, incompatibility matrix, where sort of the columns would be labeled by feature. So it could be something like SWMR, VDS, region reference data type, something like that. And then, so you would have this matrix of rows and columns, and then into a cell, there should be an S for sequential maybe, which means that, okay, these two rows and columns, these two features are compatible in sequential mode, for example. If there's a P, that would mean, for example, well, not only are they compatible in sequential mode, they are also compatible in parallel mode. And there could be a third or a fourth entry that, let's say, C for caveat or something like that, if there are additional considerations, things to be aware of if you use these things together, or something else where either they are incompatible or incompatible under certain circumstances. And but yeah, having a matrix like that, I think, would be great. It's not a replacement for good documentation, but at least I think users could sort of get a quick overview of yeah, what goes together and what doesn't, or where do I have to look more carefully. And then, but my question would be, off the top of my head, I don't know for VFD SWMR if this issue actually continues for VFD SWMR. I don't know if the fact that SWMR functionality there is implemented at the VFD level, if that makes any difference. I think free space, well, space management works differently. I don't know. Elena, do you know, or Quincy, do you guys know?
I believe it's not used, so there will be the same problem.
Okay.
So, but we need to check. Well, my just recollection is, but I don't know. Maybe it was enabled now, but I doubt.
Okay. Good. Well, unfortunately, we are out of time. And thank you for coming as always. And keep asking questions. And we'll be back next week. And stay cool wherever you are. But it's pretty hot these days. And yeah, I'll see you next time. Bye.
Bye.
See you.